Hello everyone. In this video series, I am going to discuss about abrasive jet machining process. So abrasive jet machining process is one of the unconventional machining process based on the mechanical energy method. In mechanical energy method, the material is removed from the workpiece by means of mechanical erosion. So in the abrasive jet machining process, the high stream speed of the abrasive particles mixed with the high pressure air or gas are injected through the nozzle where the workpiece to be machined. So in this process, the most common parts are the mixing chamber, nozzle, pressure regulators, filter, compressor and the vibrating device. So most commonly used gases are nitrogen, carbon dioxide and compressed gas, and the various abrasive particles are used in this process for removing the material from the workpiece. For example, aluminum oxide, silicon carbide and dolomite and glass powder and specially prepared sodium bicarbonate. So we already know about aluminum oxide and silicon carbide. The aluminum oxide is these general purpose abrasive particles. So this aluminum oxide is used in this size from 10, 20 and 50 microns. So silicon carbide is generally used for machining the extremely hard material. Here it is used in the size of 25-50 microns. Then dolomite of 200 gram size is suitable for the light cleaning. And the glass powder, in this process we are using 0.3 to 0.6 mm of glass powder. It is also suitable for the polishing and deburring effect. So the nozzle is made up of tungsten carbide and synthetic sapphire, that is called as ceramics. So the average lifespan of the tungsten carbide is around 12 to 20 hours, and synthetic sapphire or ceramics, the average lifespan of 300 hours. So the nozzle tip clearance from the work is in the distance of 0.25 to 0.75 mm. The nozzle tip clearance is nothing but the distance between the workpiece and the tip of the nozzles. So let's see how the abrasive jet machining process working. So from the atmosphere or from the cylinders, the gas or dry air is entered into the compressor. The main function of compressor is to increase the pressure of the gas or air. So here the working pressure of the dry air or gas is 2 to 8 kilogram per centimeter squared. Then that compressed air is entered through the pipeline into the mixing chamber. From the copper, the abrasive particles are entered into the mixing chamber. So in the bottom of the mixing chamber, the vibrating device is attached. So due to the vibrator device, the amplitude is controls the quantity of the abrasive particles and gas mixture. So from the mixing chamber, the high stream, high pressure abrasive particles is flow into the nozzle. This nozzle is made up of tungsten carbide or synthetic sapphire, that is ceramic. The function of the nozzle is to increase the speed or velocity of the that mixed abrasive particles. The velocity of the stream is around 300 meter per seconds. So due to the high velocity of abrasive particles mixed with the compressed air, the repetitive action of the that high stream of abrasive particle mixture, the material gets loosened and the material is removed from the workpiece. So this process is suitable for machining the hard materials and non-metallic materials such as glass, ceramics and mica. And this process, there is no direct contact between the tool and the workpiece, so there is no heat generation. So in this process there is no thermal damages. The initial investment of this process, this setup is low, but this process has some limitations, like the machining accuracy is low and the material removal rate is also slow. So the nozzle is made up of tungsten carbide or ceramic. It undergoes the high wear rate, and also the soft materials cannot be machined by this process. So these are the limitations of abrasive jet machining process. So from next video series we will discuss about one by one other unconventional machining process. Thank you for watching.